video, I want to review the different terminology regarding types of angles that we look at in geometry. Now, we're talking about Euclidean geometry, that geometry developed by Euclid, and his geometry was based on a plane, flat surface, and his geometry is based on the parallel postulate, which says this: if I have a line and I have a point that's not on that line, there is only one line I can draw through this point that will be parallel to this line. This is Euclid's fifth postulate. So here I have these two lines, we'll call them L1 and L2, and these lines are parallel, which means they will never intersect. All righty, let's create some new angles by taking a line that will pass through both of these lines. So I'm going to draw this line, here it is. I'll call this line T, which stands for transversal. And a transversal is a line that cuts through two or more lines. Now, when we talk about angles, single angles, we can talk about the acute angle, right angle, obtuse angle, straight angle. Acute angle, right angle, obtuse angle, and straight angle. And these angles are defined by their measurements. An acute angle measures less than 90 degrees. So somewhere greater than 0 degrees, but less than 90 degrees. A right angle measures 90 degrees. Right angle measures 90 degrees. An obtuse angle is more than 90 degrees, but less than 180 degrees. An obtuse angle, less than 180 degrees, but more than 90 degrees. And the fourth type we have is a straight angle, a straight line, and that measures 180 degrees. Now you can see that when I drew this transversal, I have 1, 2, 3, 4, 5, 6, 7, 8 angles in this diagram. I'm going to number those angles. So 1, 2, 3, 4, 5, 6, 7, and 8. Now we see some interesting things here. 1 and 2, 2 and 4, 1 and 3, 3 and 4, these angle pairs form a straight angle. Now, when angles form a straight angle, we call them supplementary. And we think of supplementary as two angles whose sum is 180. So for example, the measure of angle 1 plus the measure of angle 2 add up to 180 degrees in this example. Another pair of angles, were they to add to 90 degrees, would be complementary. Complementary would be if we had two angles, say an angle X and an angle Y, and their measurements added to 90 degrees. A third type of angle pair would be vertical angles. And vertical angles are those, if you will, that point to each other. For example, this angle pointing to that angle would be vertical. And vertical angles are formed when two lines intersect. So if I have two lines and they intersect, the vertical angles point to each other. And they have the same measurement. For example, in our diagram, 1 and 4 are vertical, 2 and 3 are vertical, 5 and 8 are vertical, 6 and 7 are vertical. And the measure of two vertical angles are equal. So for example, angle 5's measure is the same as angle 8. Now another important pair of angles that are formed when two lines intersect are corresponding angles. Now these are angles that are on the same side of the transversal, but they are not next to each other. Example, 1 and 5 would be corresponding. Their measures would be equal, 1 and 5. 3 and 7 are corresponding. 8 and 4 are corresponding. 2 and 6 are corresponding. Notice that they do not touch each other. They're not next to each other. And notice one is outside of the two parallel lines. One is inside the two parallel lines. 1 and 5, 3 and 7, 2 and 6, 4 and 8. And the fifth type to mention would be alternate interior angles. So alternate, one is on one side of the transversal, one is on the other. Interior, they are inside the parallel lines. Their measures are equal. For example, angle 3 equals angle 6. Measure angle 3 equals measure angle 6. And 5 and 4 are also alternate interior. Their measures would also be equal. Okay, let's see how we can use these definitions to find angle values. So I have my diagram. I have one transversal intersecting these two parallel lines. Now, let's give some values. So let's suppose this angle is 40 degrees. And I can use the fact that angle 2 is 40, and I will find the measures of the other 7 angles. There are many things I could do first. Well, for example, angle 2 and 6 are corresponding. So 6 also measures 40 degrees. Angles 2 and 3 are vertical. So 3 is also 40 degrees. 1 and 2 are supplementary. So 1 and 2 have to add up to 180. So 1 has to be 140. 140 and 40 add up to 180. Now 1 and 4 are vertical, so that's 140. 4 and 5 are alternate interior. 5 is 140. And then 8 is 140. And then 6 and 7 are the same, and 7 is 40. That's how we would do it. Now, let's change it up. Let's notch it up a little bit. And let's add a second transversal. Let's add a second transversal. Now, one way we could do that, let's just put in a second transversal right here. And let's call this line T1 and this T2. And let's suppose these lines, T1 and T2, are also parallel to each other. Let's number these angles. Let's come up here, 9, 10, 11, 12, 13, 14, 15, 16. Now, let's suppose angle 2 is 60 degrees, just to notch things up. And from this, we can get all of these angle values. You see, if 2 is 60 and these lines are parallel, well, then 11 is 60. If 11 is 60, 10 is 60. If 10 is 60, 14 is 60. You see how we're going here. And then 13 has to be 120, as they have to add up to being 180. 15 would be 60. 7 would be 60. 8 and 13 are alternate interior, 120. These are vertical. These are vertical. Now, 60 and 1, these two angles have to add up to 180. That's 120. 60 and 120, we just said that of all of them, 120, 120. There you go. For the third example, we'll take a similar diagram. We'll again have two transversals, but this time we'll do something a little different. So I'm going to have two parallel lines, L1 and L2. I'm going to have two transversals, T1 and T2. But now you can see our transversals are not parallel. So I need an angle on transversal 1 and one on transversal 2. So let's see. Well, let's call this angle 40 degrees. And let's see. See, that's on T1. Let's call this angle 30 degrees. And let's number the other angles. So actually I'll number all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. And let's number these, and I'll show you an interesting result. Now, I've got to be careful. You see now 30 and 6 are vertical, because remember, vertical angles are formed when two lines intersect. When L1 intersects T2, 1 and 6 are vertical, so 6 is 30. Now, since 6 is 30, 9 is 30 because they are alternate interior, which makes 14 30 because they're vertical, which makes 10 150 because they're supplementary. 13 is also 150 because they're vertical. Over here, 40 is angle 8, so is angle 11. But then 7 and 12 are each 140, so they add to 180. Now, since 8 is 40, now be careful here. See, 8 is 40, and I want to come up, I want to hop this side of the transversal. So 4 is also 40. Now, notice something here. Then angle 3 is 40 degrees. Well, let's see, 40 plus 30 is 70. And 70 and 110 would add up to 180 because these three angles have to add up to 180, making this 110. Now, unfortunately, the diagram is not too well to scale to show that that's actually 110 degrees, but that's what it would be. Now, this angle of 150 on this side of L1 would be corresponding here, which would be 150. So notice how it all checks out. Now, what's interesting, take a look at these three angles that are the three angles of a triangle, and notice how they add up to 180, showing us that the angles of a triangle add up to 180. Alrighty, this gave you a little review of angles and how we use them in finding values when we work with parallel lines.